Hello people, welcome to Gurukula. I'm Jai. So today in this video we are going to see about the topic called as protocol layering. So we very well know what exactly the protocol is, and now we will throw some light on understanding why is protocol have been arranged as layers in order to accomplish and successful communication between one point to the other point. So all the contents and all the modules that we are going to discuss in this particular video will make you to understand why the protocols are being formed as layers over here. So without any further ado, let's get into the topic. So first of all, to understand why the protocols have been layered is what? When we are communicating from one point to another point, when we definitely need a protocol which governs the communication from one point to the other point. So if it is a very simple communication, let us assume that I am just trying to communicate from one point to another point in a very simple way. Let us assume that this as a scenario 1, and here I am trying to establish a face-to-face communication. So when I am actually communicating face to face, I really don't need a bunch of protocols which is governing my communication. All I have to ensure is both the sender and the receiver must agree upon a common language to communicate with. So agreeing upon a common language will be the only prime task which I have to perform if I am communicating in an face-to-face communication. So in this simple scenario, in this simple communication, we actually do not require hell lot of protocols working for effective communication from one point to the another point. But when it comes to complex communication, let us say that I wanted to send an email from my system to my friend's system. Then obviously we need a sets of protocol, more number of protocols which has to work together and simultaneously so as to ensure the effective delivery of my emails to my friend's mailbox. So let us take a closer look on it. So let's take for an example, I wanted to send an email from my system. So definitely one layer of protocol is responsible for capturing my email. So this is what you can relate this to your email application, where you type in your from address to address and then the content of your email. So that will be my first layer. And the second layer is I will have to encrypt all the emails, because my email is going to enter into a private network, private internet. So that in order to keep it safe, I wanted to encrypt all the contents whatever I have typed over here. So another layer of protocols or another layer of actions is required to encrypt my email, and one more layer of protocol is required so as to effectively deliver my message from one point to the other point. So that is where we require 3 layers of protocol for effective delivery of my messages. So since, as you could visually realize, when a complex communication is getting established, then we definitely require more number of protocols that is working together so as to ensure the effective delivery of the messages from one point to the another point. So this is the reason why actually we go for protocol layering. Alright, now we clearly understood that we need more number of protocols for complex communications. But why do they need to layered? Why can't we have a set of protocol which is working together in any mode? Why is it to be layered architecture? So let us throw some light on it. So does layering actually satisfies the need? If I need to have more number of protocols, then why can't I simply have n number of protocols that is working on n communication perspective? Why should I actually layer the protocols one after the another? So let us assume that we are running a shop where you are selling a jam breads like this. So few people will be walking into your shop and then they will be getting satisfied with what you serve. Right? Now the time changes. Now actually a foodie walks into your shop and then he is asking for a customization. He is asking for the jam bread has to be really crispy or the jam bread has to be really spicy, where you really don't have sufficient space to modify your product according to the requirement of that particular foodie. Now, what if 10 people enters into your shop and then they are asking for 10 different types of jam breads. So that is really not possible for us to make the customizations that satisfies all the peoples individually. So the one and only way to satisfy them is we should have something this kind of architecture. So whereas in the burger type of architecture, the first layer and then the last layer remains the same as like what we had over here, but we have hell lot of customization options in between the first layer and then the last layer. With this layered architecture, we have complete freedom of modifying this particular burger according to the requirement of any foodie. If I have to make it more crispier, I can add any separate layer which is responsible for crispiness. If I want it more spicier, then I can add or remove any layers that is responsible for giving spiciness. So that I have a freedom of including or excluding any of the layers according to the customer satisfaction. So doesn't it clearly says that the layering is actually helping us to satisfy more number of people's requirement on the network. Similarly, every people, those who are accessing internet, will have different requirements. Your banking applications will have different requirement, your shopping applications will have different requirements, and the photo correcting applications will have different requirements. Video conferencing applications will have different requirements. So each and every application and each and every people that who are connected to internet will have different requirements. So we need a common protocol architecture to satisfy any number of people or what kind of people they are connected to the internet. So this type of customizations is possible only if we have a layered architecture of protocol. So that is the reason why we go for layered architecture of a protocol. Now when we talk about the principles of protocol layering, we have certain principles to follow while layering the protocols. There are basically two principles. The first principle says that when a communication is going to be bidirectional, then each layer that we have so that it is able to perform two opposite tasks, one in each direction. So that is the very first principle. And then the second principle is the two objects under each layer at both the sides should be identical. So let us make it more clear. When you look at this particular diagram, as per the first principle, what does it says? It says each layer able to perform two opposite tasks, one in each direction. So now let us consider this particular layer. When the message, let us assume that Maria is sending an email. So now he is the sender and now Anne will be the receiver. So Anne will be the receiver. Now in this case, email will be sent from Maria's system and it will be received in the Anne system. So when the message is communicating from this particular task at the sender side, this layer performs encryption operation. And consider the same layer again over here. Then when the email is entering in this particular direction, then this will perform the decrypt operation. So the same layer is performing two opposite tasks, one in each direction. When it is entering in this particular direction, this performs encryption, and when a message is entering in this direction, it performs decryption. The same applies in the vice versa. When the message is entering in this direction, this will perform encryption, and the message is entering in this direction, this will perform decryption over here. So that is what the clear understanding of the first principle is. Now getting to the second principle, your second principle states that two objects under each layer at both sides should be identical. So the layer what we have on the left hand side should be identical with the layers that we have on the right hand side. As you could see, the layer 3 of the sender is listen and talk. Similarly, the layer 3 on the receiver side is also listen and talk. The second layer at the sender side is encrypt and decrypt, and similarly the second layer at the receiver is encrypt and decrypt. The layer 1 at sender side is send and receive email, and layer 1 at receiver side is also send and receive email. So as you could see, there are identical objects that is present both at the sender side and then the receiver side. So these two principles has to be followed when we are establishing a protocol layering. So we cannot leave this to the hands of the network devices manufacturers or the companies that is king in establishing communication devices. So what they will do is they will manufacture their own devices by using their own architecture and their own protocol layering, leading us for incompatibility issues. So in order to avoid all these compatibility issues, the entire globe have been accepted a particular standard or model to communicate effectively. So whatever the devices that is being generated or manufactured for networking purposes, they will have to adhere to this standard, that is what we call it as OSI model. So this OSI model is a standard which is proposed by ISO, that is International Standard Organization. So here it is a set of protocol that allows any two different systems to communicate regardless their underlying architecture. So OSI actually contains 7 layers of protocols. Each and every layer will have their own task to perform. And further, they are grouped into 3 subgroups. Now we will list out what are all the 7 layers that is present in the OSI module. Starting from the physical layer, second one is data link layer, followed by network layer, followed by transport layer, session layer, presentation layer, and finally application layer. So this application layer is where actually a person sits and then he will be interacting with the system. So this is the layer that is connecting the user to a particular system. And the physical layer is the area where we actually connect our Ethernet port or we connect our system to the network. So whatever the messages that a user is trying to create on the application layer will pass through all these layers and finally it will leave our system through the physical layer. So now coming to the subgroups, the first 3 layers is what we call it as user support layers, which is actually deals with the interoperability among the software systems. The transport layer is responsible for reliable data transmission from one network to the other network. And the last 3 layers, that is network layer, data link layer and physical layer, is responsible for the physical aspects of moving the data from one device to the another device. So this is how an OSI model have been formulated, and all the devices that is manufactured to get connected on the internet should follow this particular protocol layering standard. And this standard is what we call it as OSI model. So talking about OSI, OSI stands for Open System Interconnect. So when we closely observe, here is the sending system and then the receiving system, where the 7 layers of OSI model are stacked up. As you could see, the 2 principles of protocol layering is completely satisfied here in this particular OSI module. So as per the first principle, application layer, session layer, presentation layer will perform a particular task in either direction, and as per the second principle, the layers are very much identical on the sender side and as well as the receiver side. Now, since it is in standard, we do not have the option or privilege to rearrange the order of this OSI module. So in order to remember the layers of OSI module in the same exact order, there can be a trick that can be kept in mind so that you will not rearrange the layers of OSI model. So you can always try to remember this one sentence: please do not touch Steve's pet alligator. So this one sentence will help you out to remember the layers of OSI model in an same way as it is represented in the standard. So please do not touch Steve's pet alligator. All the first letters represents each and every layer, as you could see in the figure. So with this simple tip, we will jump into each and every layer and then we will try to understand what are all the functions of each and every layer is concerned. So as of physical layer is concerned, your physical layer is responsible of transmitting a bit stream over a physical channel. So this is the prime task of the physical layer. So your physical layer will get data from the upper layer called data link layer, and all the information received from data link layer will be in the forms of ones and zeros, and your physical layer is responsible for transmitting this data in suitable format over the transmission medium. So the mechanical properties and the electrical properties will be taken care by the physical layer. The mechanical properties relates to what kind of port am I using. Am I using an Ethernet port so that my messages should take the electrical form? Am I using a fiber optic cable so that my messages should take an optical form? Am I using a wireless connection so that my messages should take EM wave, means the radio waves format? And also it will take the electrical properties of the interface that is required, whether it is 5 volt or it is 12 volt, depending upon the system and then the requirement. So in addition to these particular prime tasks, my physical layer also deals with, it decides the transmission rate, the speed of transmission, and it also decides the physical topology of how the systems are getting connected, and it also deals about the bit synchronization. So these are all the various functions that will be taken care by the physical layer. Now coming to the data link layer is responsible for sending a group of packets to the adjacent node without any errors. And we also call this particular function as node to node delivery. It is important to make a note of this particular delivery, because in a short time we will be discussing 3 more types of delivery, so that you should be in a position to differentiate which layer performs which type of delivery. So data link layer is responsible for node to node delivery. So data link layer is supplied from the network layer, which means it gets information from network layer, and then your data link layer will perform the following task. It will perform the framing operation, it will perform physical addressing, it will perform flow control, error control, and then access control. So what do you mean by framing? So framing is nothing but addition of redundant bits. We call it as header and then the trailer. As you could see in the figure, we can add header and then trailer is being added to our actual data. So the process of adding redundant information to our actual data is what we call it as framing. Why do I need to frame a particular data? Because the header will contain sufficient information and useful information so as to represent the start of the frame. That will also represent what addressing type have been used, and then the quality control data. And the trailer will represent the error detection part, and also that will include the that will actually include certain number of bits which represents the stop of the frame. So that is what we call it as framing. And the physical addressing. So physical addressing refers to the source address and then the destination address. The source address and destination address will be represented in the header part, which will allow the packet to get delivered to the right destination. And flow control are the mechanisms which will govern the flow of information inside the network without any congestion. Error control are the mechanisms which will take care of minimizing the errors which occurs due to the communication part. And then finally, access control will take the responsibility of who can access the particular channel and on what basis. So all these functions of data link layer will be discussed in detail as the course progresses. As of now, it is enough to understand what is what. So next, jumping on to the third layer, your third layer is network layer, and your network layer is responsible for source to destination delivery. So I would like to recall in previous layer, that is your data link layer is responsible for node to node delivery. And as against to your data link layer, your network layer is responsible for source to destination delivery. What is the difference? So your data link layer, as you could visualize that your system is connected to the destination. Let us say that this is my PC and this is what the server which I wanted to get connected with. Let it be an google.com server or facebook.com server. So when I want to get connected, when I want my PC to get connected to the server, my PC is getting connected to the server through several intermediate devices, as you can visualize here. So here what I could do is, if my packets are getting delivered from my PC to the immediate next node, then this delivery is what we call it as node to node delivery, or it can be also called as hop to hop delivery. Alright, so then what is source to destination delivery? In our case, my PC will be acting as the source, and then the server will be acting as the destination. So if my packet is getting delivered from my source to destination through several intermediate devices, then this entire route is what we call it as source to destination delivery. So my data link layer will take this is what my data link layer is. My data link layer will take the responsibility of delivering my data to the immediate next node without any error. But whereas your network layer is responsible for delivering all your packets from source system to the destination system. So that is what the primary functions of the network layer is. So the primary function of network layer also includes logical addressing and then routing. So logical addressing is nothing but addressing a particular system in a very logical way, and very best example is you might have come across IP addresses such as 192.168.10.01. So likewise you might have seen IP addresses, and this addresses is what we call it as IP address, Internet Protocol address, and this is what we call it as logical addressing. And the second functionality of network layer is the routing actually. So routing is nothing but routing the packets in the right direction to reach the correct destination is what we call it as routing. So the protocols and algorithms that is responsible for routing will be taken care by the network layer. So coming back to the fourth layer is transport layer. So your transport layer is responsible for end-to-end delivery of the entire message. So I would like to recall it again. Your data link layer is responsible for node to node delivery, and then your network layer is responsible for end-to-end delivery, and now transport layer is responsible for again end-to-end delivery. Now what makes the difference? Your data link layer and network layer are responsible for node to node delivery or end-to-end delivery of a particular packet, and your transport layer is responsible for end-to-end delivery of entire message. So now what do you call it as message and what is called by packet, we will see in a minute. So in transport layer, the primary functions of transport layers are service port addressing, segmentation and reassembly, connection control, and then flow control and error control. So in addition to the data link layer, your transport layer will also include some amount of flow control and error control, which will be discussed in the later part of this particular module. So now let us talk about what exactly the segmentation and reassembly are. So segmentation and reassembly represents to a process of dividing a very longer message into small chunks of packets is what we call it as segmentation. So in a network, a particular link that is connecting one node and then the another node will have a certain amount of capacity. So let us say this particular link can able to handle only 10 bits at a time. So if the message generated by this sender device is for 20 bits, which I have to transmit from this source to destination, then this particular link could not handle 20 bits at a time. So what happens is this 20 bits of data will be divided into two chunks of data, one into 10 bits and another part which carries 10 bits. So this 20 bits of data will be transmitted as two different parts. So this is what we call it as packet 1 and this is what we call it as packet 2. So as we could clearly see that my message is being converted or it is segmented into several number of packets. So the number of packets will be decided by the maximum capacity of the link. So a very long message will be segmented into small sections, and each and every small section we call it as a packet. And all the packet will travel in different routes on a network, and finally it will reach the destination system. And there at the destination system, each and every packet will be reassembled back, and then it will be combined, and then an entire message will be delivered on the recipient system. So this process is what we call it as the segmentation and then reassembly. Whereas your data link layer and then the network layer will take the responsibility of end-to-end delivery or node-to-node delivery. Your data link layer is responsible for node-to-node, and whereas your network layer is responsible for source to destination delivery of a particular packet, and whereas your transport layer is responsible for source to destination delivery of entire message. Now I think you might have a clear understanding of what messages are and what packets are. So talking about service port addressing. So service port addressing in network communication, you might have come across three different addressing. So first one is physical addressing. So physical addressing, and second one is logical addressing, and third one is port addressing. So what does all these three represents for? So physical addressing is what we also call it as MAC address, which is a permanent address of any network devices. So each and every device that is getting connected on the internet will have an permanent address which is embossed on your network interface card. So this is not able to change. So this is permanent for your system until it goes to the trash. Logical address is what, again, another type of address which is assigned to any system that is on the internet, so as to, which is assigned in a logical way, so as to identify on which network the system is present. So that is what we call it as logical address. So port address is something we represent for representing the process that is running on a particular machine. That is why sometimes it is also called as process ID. So in order to make it very clear, physical address can be related to a name of a person. So my name is Jay, which is not going to change during this lifetime. So that is what my physical address is. So whomsoever wants to address me with my permanent name, so they call me Jay. And my logical address depends upon the place where I am working. So when I was studying, I was called as student, and when I was working, I was called as assistant professor. When I am doing my research, I will be called as research scholar. And once I complete my PhD and gain sufficient experience, I will be called as professor. So these are all the various designations which I hold in my career. So this is what I can closely relate it to logical address. So the address which I possess is being assigned to me in a very logical way. So it depends upon the place where I am working or studying, or it depends upon the role that I am playing. So that is what we call it as the logical address. Now there is something special address, we call it as port address. So port address is nothing but on a particular machine. Let us take that this is my machine which is located over here. When I open a Chrome tab, then in first tab I am working on email application, and on the second tab I am working on WhatsApp, that is my instant messaging application, and in third layer I am streaming some Amazon content, and in fourth tab I am trying to download a particular file. So file download is happening. So likewise, in one particular machine there are several processes running. So if I receive any particular email, that has to be delivered to this particular tab, and if there is any messages which I receive through WhatsApp, then that should be delivered in this particular tab. So how do I represent, or how do I differentiate all these tabs, is what by using the port addressing. So each and every tab uses different protocol, depends upon the type of application that I am using. If I am surfing a web, then a different type of protocol will be used. We call it as HTTP. If I am trying to download a file, then I can use FTP protocol, which helps to download a file. So if each and every protocol will have different port addresses. So as you could see over here, my system is running two processes. The first process is dealing with file transfer protocol, and then the second process is dealing with surfing a web. It is trying to fetch a website on the internet. As you could see, FTP, all the traffic that is generated through this FTP process, that is file transfer protocol process, have been assigned a different port address. And the traffic that is generated by the web services have been assigned a different port address. So any information or any packet that is being received with this particular port number will be delivered to that particular process. So that is what we call it as the port addressing. Your transport layer will take the responsibility of assigning the port addresses. And when we talk about the port addresses, there are some known port addresses and then unknown port addresses are also there. Not all the protocols have been assigned with port addresses. There are few port addresses, whereas FTP and web comes under the known category. There are several other unknown protocols that is running, and where the transport layer will assign any random port address for a temporary connection. So next, coming on to the session layer. Your session layer is responsible for establishing, maintaining and synchronizing the interaction. So the primary functions of session layers are dialog control, synchronization, etc. So this you can closely relate it with your session layer is responsible for establishing a session between your PC and then your server. For example, let us consider that this is my bank's server. So your session layer is responsible for creating a dedicated session or a dedicated connection between your PC and then the server, which is valid for 5 minutes or 10 minutes. If the system encounters 5 minutes or 10 minutes of inactivity, then this particular session will be terminated, asking you to re-log in again. You might have experienced this particular feature on your banking websites and as well as the IRCTC websites. So any inactivity exceeding a particular threshold minutes will automatically log you out, considering the safety precautions or managing the traffic to the particular server. So this feature is what being incorporated, or this feature can be brought in to any particular application by the use of the session layer. So the presentation layer is responsible for presenting the data in a suitable format or in a reliable format. So the primary functions of presentation layers are translation, encryption, decryption and then compression. So any of your messages may undergo certain kind of translation, encryption and then compression as well. So any messages that has to be translated, encrypted and decrypted will be performed by your presentation layer. And another important function of presentation layer is your presentation layer is responsible for delivering the messages on the suitable devices also. Let's say for an example, I am loading a facebook.com on my laptop. I am trying to open the same website on my tab, and I am trying to open the same website on my mobile. So facebook.com is one single domain and I am trying to open it on different varieties of devices. So the visual representation of facebook.com gets differed from device to device. So your presentation layer is responsible for delivering the right form of data on the right devices. So that is the primary function of the presentation layer. So finally, coming to the application layer, this is where it interfaces user with the system. So the layer at which we work on different applications is what we call it as application layer. So we use different applications for email services, we use different browsers for browsing applications, we use different applications for online shopping services, and we use different applications for money transfer. So each and every requirement will have different applications that is running on our PC. So application development by any of companies will be done at the application layer, which is actually interfacing the end user and then the system. So this is what we call it as the application layer, and these are all the 7 layers which is coming under the OSI module, and each and every process of every layer have been discussed in detail. So I will wind up the video with this particular topic, and these are all the references which I have taken all the content, so you can actually go through. There is no online references for this particular video, and all the contents whatever I have delivered have been taken from the first 2 textbooks. So with this, I'm going to see you on the next particular video. Until then, happy learning.